Welcome back. Continuing with our lectures on section 3.2, mean value theorem. Okay. Now, our main use of Rolle's theorem is in proving the following important theorem, which was first stated by another French mathematician, Joseph Louis Lagrange. Now, this is a famous mathematician, okay, Lagrange. But anyhow, continuing with mean value theorem. Let f be a function that satisfies the following hypothesis. So, notice this is very similar to Rolle's theorem. You're requiring your function f to be continuous on the closed interval ab. You're requiring that your function f is differentiable on the open interval ab. Okay? Unlike Rolle's theorem though, you're not expecting f at a to be equal to f at b. You're simply saying be continuous on the closed interval, be differentiable on the open interval. Geometrically, continuity means what? Your curve is not broken. Geometrically differentiable means what? Your curve is smooth. There are no pointed points. All right. So let's look at a few examples. Right? So here is height at A. So the point at A is AFA. Here is B and the height at B. The point is BFB. Your function is continuous and smooth, right? So if the heights are different, what can we say? Now look at the picture. You have a certain slope, right? There will be a point in between where you have the same slope, right? This line is parallel to this line. So that is the slope is equal. Okay. Now, here is another option. This is corresponding to point A and that is corresponding to point B. Notice heights are different. Heights are different means you have a non-zero slope. There will be point, at least one point, where the tangent is parallel to the line joining end points. In other words, the slope of the tangent is equal to the slope of the line segment joining the end points. All right. So what does mean value theorem say? If you have a continuous and smooth curve joining two points, then there will be a point in between which has slope equal to the slope of the line segment joining the endpoints. That's all we are saying. So remember the endpoints AFA, BFB. That will come in handy. Okay. So f is continuous on the closed interval AB, f is differentiable on the open interval AB. There is a number c in AB such that the slope of the tangent at C, that is f prime C, is equal to the slope of the line segment joining the endpoints. Do you understand this formula? y2 minus y1 over x2 minus x1. So notice the first point is AFA. So this is x1 and y1. The second point is BFB. So this is x2 and this is y2. All right, look again. AFA. So this is x1, this is y1. BFB. This is x2, this is y2. So y2 minus y1 over x2 minus x1. That is f prime. All right. Now by cross multiplying, think of b minus a as one item. This guy has denominator 1. 1 times this, that's the left hand side, equals f prime c times this. That's the right hand side. So mean value theorem can be stated either in this fashion or in this fashion. They are both okay. But the theorem, note the theorem means you start here and end here. That's the theorem. So make sure you read this, write it 5 times, make sure you understand it. Okay. So here were pictorial examples. Now we want to, uh, yeah, so this is the slope of the line segment joining the end points. Okay, we got that. Okay, so I will stop here for time being. Continue with the next.